During class today, we'll be looking at a few review activities for exponential growth and decay. The first one is on Desmos, so we'll do that one in class on the computers. And the second activity will look at review problems. So I'm going to go over some of these review problems with you right now. So number one, it says find a bank account balance if the account starts with $100, has an annual rate of 4%, and the money left in the account, and the money is left in the account, it should say, for 12 years. So for this one right here, let's write the equation first. I'm going to underline the important information. So $100, annual rate of 4%, the money is left in the account for 12 years. So we have y equals our starting value. It's increasing, so 1 plus. We're going to change the 4% to a decimal, so you can divide 4 by 100, or move the decimal place over twice, so it's 0.04. And then it's exponential, so t is the number of years. And here t is 12 years, so we have y equals 100, 1.04 to the 12th power. In our calculator, we'll type in 100, and then we have the 1.04 to the power of 12. And so if we keep the money in the account, we're going to get $60.10 interest, and we'll have a total of $160.10. Let's try the next problem. In 1985, there were 285 cell phone subscribers in the small town of Centerville. The number of subscribers increased by 75% per year after 1985. How many cell phone subscribers were in Centerville in 1994? So let's underline the important information and write the equation. So we have our starting value 285. It's increasing by 75% per year. So 1 plus the 0.75, and then t is time. So from 1985 to 1994, let's figure out how many years that is. So that is 9 years later. So in our calculator, we'll type in 285 times 1.75 to the 9th power. So 285, 1.75 for 9 years. So it jumped to 43,872 cell phone subscribers. Number 3, bacteria can multiply at an alarming rate when the bacteria splits into 2 new cells, thus doubling. If we start with only 1 bacteria, which can double every hour, how many bacteria will we have by the end of 1 day? All right, so 2 new cells. We start with 1 bacteria, doubles every hour, end of 1 day. Okay, so y equals, we start with 1, it doubles. T is the number of hours, so here in 1 day there's 24 hours. So we can just do t 2 to the 24th power. So at the end of 1 day you'd have a lot. You'd have 16,777,216 cells. That's quite a bit. Number 4. Oops. Each year during each of the local country club sponsors a tennis tournament. The play starts with 128 participants. During each round, half of the players are eliminated. How many players remain after 5 rounds? So here we start with 128 teams. And here it's going down 100% minus half. And t is the number of rounds. I'll put the 5 here. We know it's 5 rounds. So in our calculator we have 128. Cuts in half every time for 5 rounds. We'll type that in. Whoops. 128.5. And there's only 4 teams left. at the end of 5 rounds. Let's try a few more. Well, it's just 3 more. The population of Winnemucca, that's how you say it, Nevada, can be modeled by this equation, where T is the number of years since 1990. What was the population in 1990? By what percent did the population increase each year? Well, the starting value is the first number, and so in 1990 the population was 6,191 people. By what percent did the population increase? So that would be, an increase is the 1 plus, and it's adding the 0.04, so it's an increase of 4% per year. Number 6, you have inherited land that was purchased for $30,000 in 1960. The value of the land increased by approximately 5% per year. What's the approximate value of the land in the year 2011? All right, so here we're going to start with our land, $30,000. It's increasing by 5% per year. And T is the number of years since 1960. So you need to figure out how many years it is from 1960, 2011 minus 1960. Okay, that's 51 years. So we have y equals 30,000, 1 plus 0.05 for 51 years. Let's see how much this is worth now. $51 and 31. And now it's worth $361,223. That's quite a lot of money. And the last one, you buy a new computer for $2,100. It decreases, the computer decreases by 50% annually. When will the computer have a value of 600? So let's write the equation. Starting value 2,100 decreases 50% per year. Oops. And we want to know, when will the computer have a value of 600? So this one right here, we haven't learned how to solve for t when it's a variable. So we're going to try guess and check. So I'm going to type in this part of the equation and just guess values of t till I get 600. So let me clear this. All right, 2,100, and it's 0.5. And I'm going to guess the number of years. Try 3 years first, just to see how close I get. Again, I want it to be 600. So 3 years is too quick. I mean, too much. So I have to go less than 3 years. I want to get 600. I'll try 1.5 years. Oh, it's close to 1.5. Let's try 2 years. Try 2 years. Okay, so it's in between 1.5 and 2 years. Try 1.75. Okay. So I need to go a little bit higher than 1.7 years. Let's try 1.8. All right, I'm going to say 1.8 is pretty close. I'll try a little bit more. About 1.85. Nope, that's a little bit further away. How about 1.81? Okay, so this is about $2 apart. It's about $3 apart. I'll just say about 1.81 years. It's about... It's almost 2 years. All right, so again in class we'll do an activity on the computer and then you'll practice these word problems.